Okay, we have a man standing alongside a river that is 2 miles wide. He needs to cross that river to get out of location 8 miles up the river. He can row his boat 4 miles per hour and run 6 miles per hour. What is the fastest he can make this trip? You may want to pause the video and write this down. Okay, so I'm going to draw the river, and I'll just make it in blue. So here's my water. Let's say the man is standing at point A, and down the river at point B is where he's going. Now, the river is 2 miles wide, and point B is 8 miles down the river. Okay, so there are several different ways this could happen. The first possibility is that he rows his boat straight across the river and then runs down the bank on the other side. And let's examine the time that it'll take him. Now remember, your basic formula is distance equals rate times time. I'm going to put that in capital T. What we're interested here is the fastest he can go, so we want to minimize the time, which means I need the formula in terms of time. So if I solve for t, we get t equals distance divided by rate. Now, this is just a general concept. We've got two situations going here, so I need to account for each time for when he's rowing the boat and when he's running. So, let's talk about the first situation. He has a distance to row a boat that's 2 miles, that's fixed if he goes straight across, and he can row his boat at 4 miles per hour. So that's the time it'll take him, 1/2 hour, to get across the river. And then he can run it down the bank. He has a distance of 8 miles to go, and he runs at a rate of 6 miles per hour. So if he directly crosses the river and then runs down it, it will take him a total of approximately 1.83 repeating hours. Okay, that's option number one. Option number two. Let's say he attempts to row directly from point A to point B, and I'm going to draw the best line I can. Okay, so in this case, we just need to know the distance directly from point A to point B. Well, I've got a triangle here, and I've got Pythagorean's theorem, so this distance will equal the square root of 2 squared plus 8 squared. 8 squared is 64, 2 squared is 4, 4 plus 64 is 68. So that's the distance directly in miles from A to B, which is just a little bit under, or a little bit over 8 miles, so it's 8.2 miles approximately. But I'm going to leave it in my calculator exactly as that. So the time for him to row directly over is the distance, which is square root of 68, over the rate at which he can row his boat. And that will give me approximately, 2.062 hours. Okay, so clearly right now it's better for him to row straight across than to row directly to it. So right now, of these extreme options, the best choice would be straight across. There is 1/3 other option. And let me erase this. And that is if he rows from point A to some point between straight across and point B. We'll call this point C. And then he runs down the river bank that remaining distance. Okay, so a couple things here. I'd have to figure out the distance that he was rowing, and I don't know how far along the bank he's going to be at point C. So I will call the distance on bank from straight across to point C x. Now, the total distance on the other side of the bank is 8 miles, so the remaining distance is simply going to be 8 miles minus x. So I need to get all my distances in terms of x. So I've gotten this distance in terms of x, but not this distance. So to do that, I'm going to use the Pythagorean Theorem. And the Pythagorean Theorem for that distance, again, let's take a look at the triangle. It's a squared, which is 2, plus b squared, which is x, gives you c squared in this case, which would be d. So d squared would equal 2 squared plus x squared. Take the square root of both sides. And I have my distance. Okay, so now we're going to make the fastest time that he can get across. So first we have the distance that he has to row the boat, which we just calculated. Oops. Divided by the rate at which he can row the boat, which is 4 miles per hour, plus the distance he has to run, which is the rest of that distance, over how fast he can run. Now, I'm going to rewrite this slightly, but this question now becomes find the critical point, because you've already found the extreme points on your domain, and that is the shortest distance he can row, which is straight across, to the longest distance he can row, which is straight to it, and now we have something in between. So, before I take the derivative, I'm going to just write this slightly different. So, let's see what we have here. And he can row 4 miles per hour. Yes, okay. Sorry. And, yeah. Eight over 6, I'm going to separate as one fraction, which is the same as 4 over 3, minus 1 over 6x. There's a reason, so I can take the derivative the easiest. So now I'm going to take my derivative of time with respect to x. This is on the outside of power function, so I'm going to multiply everything by 1/2. So when I do that, 1/2 times 4 is going to make it 8. And I need to subtract 1 from the exponent. That's going to make it a negative 1/2 exponent, or I can simply write it on bottom with the 1/2. And now I'm going to take the derivative of the inside, because I have to use the chain rule, or u substitution, and inside the function 4 plus x squared's derivative is 2x. The derivative of this component is 0, and the derivative of the last term is negative 1 over 6. And I'm going to set all of that equal to 0 to find my critical points. First of all, you should recognize this 2 and 8 reduced to 1 and 4. Technically, you don't have to write the 1 because I already have an x, and it's assumed to be 1x. Now, I'm going to add 1/6 to both sides. Okay, now I'm going to couple things we could do here. First thing I'm going to do is multiply both sides by 6. And then I'm going to reduce my fraction. 6 over 4 reduces to 3 over 2. So I have 3x over 2 times the quantity 4 plus x squared raised to the 1/2 equals 1. I'm going to multiply both sides by my denominator. Okay, after reducing, I multiply both sides by the denominator. Now, I'm going to square both sides to get rid of my 1/2. When I square both sides, I get 9x squared equals 2 squared is 4. The square root of this squared just gives me that. I'm going to simplify with the distributive property. I'm going to put the x squareds on both sides by subtracting 4x squared. And solving for x, which gives me square root of 16 is 4 over the square root of 5 as my x value. So the question was, let's just back up to that. What is the fastest he can make this trip? So I have a formula for that time. I have a critical number of 4 square root 5. I'm going to plug it in to that formula right here. Let me highlight the formula I'm about to use. And I'm using it with the critical number that we just located. So always back to basics. Critical number and your domain. You might want to notice this part, x was, let's see, for the green equation, x equaled 0. We were going straight to the, x equaled 8 because we went straight to point B. On the red part, x equaled 0 because we went straight across and then ran. This is my extreme situations. This is the domain, my endpoints. So I've already taken care of the endpoints, just hadn't realized it yet because I hadn't built the equation. Now I have the equation. It will also work for those endpoints, but now I'm going to plug in my critical point. And again, the critical point is 4 over the square root of 5. Come on, calculator. There we go. So, I'm going to put 4 divided by the square root of 5, and I'm going to store that. Second function, just store as x. Now, my formula is parentheses 4 plus x squared to the 1/2. I probably should have just made that a radical, but oh well. 1 divided by 2, all divided by 4, plus, actually I'm going to go back to the original, 8 minus x divided by 6. So when I plug in my critical point, I get 1.706. double check that. Yes. I'm going to compare that with the other 2 times of 1.8 hours, that's more. 2 hours, that's more. These are my endpoints. This is my critical point, and it gives me the fastest time, which is 1.706 hours. Let's convert that to proper. So this will be 1 hour minus 1 times 60, 42 minutes, minus 42 times 60, 21, we'll call it 22 seconds. We'll round to the nearest second. So the fastest conceivable time is 1 hour, 42 minutes, and 22 seconds for him to make this trip.